Making hole. It means drilling into the earth to create a path from the surface to an underground reservoir of oil and gas. Making hole, a deceptively simple term for a less than simple process. Making hole is drilling through thousands of feet of earth to reach oil and gas. It takes thousands of feet of heavy steel pipe, several very tough drill bits to cut through solid rock, a derrick often more than 100 feet high, powerful engines, and plenty of elbow grease working round the clock, 24 hours a day to find and tap oil and gas, our primary energy resource for this millennium and beyond. Making hole, finding and recovering oil and gas, is a treasure hunt, a scramble for a prize that takes place in unusual locales. Petroleum reservoirs lie deep beneath the surface of the earth in often inconvenient places. The result, drilling for oil and gas is an international industry, one that requires people, power, ingenuity, and equipment to get the job done. In the next few minutes, we'll explore how the industry locates petroleum reservoirs and how they drill from the surface to the necessary depths. And we'll learn how they find petroleum and how they rig up the drilling equipment. We'll also take a look at the 4 basic systems for any drilling unit: rotating, hoisting, circulating, and power. One of the first questions is, where are the petroleum reservoirs that lie hidden below the surface and thus invisible to the naked eye? How do we find them?
In the early days of oil exploration, geologists used things like the surface features and even vegetation to determine where to drill for oil, because they couldn't see beneath the surface of the earth. In the last 50 years, seismic technology has been developed to try to image the subsurface. In the last 20, 3D technology has taken over and improved the success rate from 1 in 10 to 6 in 10 in successful wells that were drilled.
Geophysicists, scientists that study the mechanics of the earth, use sound waves to help them picture what lies beneath the earth's surface. One way to make the sound waves is to vibrate a heavy weight on the surface. Surface sensors called geophones pick up the vibrations. The sound waves travel down through layers of rock. As they pass through different layers, the rock boundaries reflect some of the sound waves back to the surface. Geophones on the surface pick up the reflected waves. Special equipment records and translates the sound waves into a map or seismic section of the underground formations.
This is an example of a conventional seismic horizon slice that geologists use today for exploring for oil. Here in the lower part of the section, you see some features that we know to be buried stream channels. Contrast that with the image here, which is a coherence cube horizon slice, and that you see those same features are now revealed in high detail, and they're known to be stream channels. And you can see that they're cut by faults. Here's a salt dome with radial faulting, and the yellow areas here are direct hydrocarbon indicators in the Gulf of Mexico.
Despite all the advanced technology like 3D and 4D seismic that reduces the uncertainty of finding petroleum, the only sure way to find out if a formation really contains oil and gas is to drill for it.
The site was basically just pasture land. This country around here is kind of hilly, so it was very unlevel. So they had to bring bulldozers in and do a lot of cutting. First piece of equipment they actually rig up at the substructure. They set the substructure and then work off it with the mud tanks and come around with the pumps and then the engine package and the FCR house. On a rig this size here, this is a 1,500 horsepower, but it's bigger than most 1,500 horsepower. It takes about 6 to 7 days to rig it down, move it, and rig it back up on like a 10 or 20 mile move.
Rigging up, setting up all the drilling equipment on land, begins with the contractor moving the equipment on trucks to the drilling site. At the site, the rig crew places all the equipment at its required position. Finally, they raise the mast and begin drilling. Offshore rig up's a different story. The Lafitte Pincay sits in the Gulf of Mexico, 25 miles from shore in 145 feet of water. It's a semi-submersible. Its hulls are submerged several feet below the waterline. Before they could drill here, they had to tow the rig to the site.
We're sitting out here in about 25 miles offshore on about 145 foot of water. We were towed out here by 2 anchor handling boats. We ran anchors and we're being held here by 8 anchors. We're going to drill this location 15,000 feet and hopefully in about 90 days. This is a semi. We have a crew on here of 75 to 80 men. We work 14 on, 14 days off, 12 hours a day a shift. We have a crew change every week, rotate around. On my drill crew, I have a driller, an assistant driller, derrick hand, and 3 roughnecks. I have a 6-man roustabout crew with a crane operator that works the decks, backloading boats, any supplies, and the drill crew which does the drilling.
This jackup rig was also towed to the drill site. Then crew members jacked the legs down to the ocean floor. They then jacked the hull up on the legs high enough to clear the tallest anticipated waves. This jackup, like all offshore rigs, serves as both a drilling unit and home to a lot of people, maybe as many as 75 or more. Jackups and semi-submersibles are just 2 kinds of offshore rigs. Oil companies use different types of offshore rigs depending on the depth of the water and the drilling conditions. Regardless of the type, however, besides the drilling equipment, they also contain a helicopter pad, docking facilities for floating vessels of all kinds to bring supplies and crews, waste treatment systems, escape vessels in case of emergency, and living quarters. An offshore rig is like a small city, complete unto itself, but with one critical difference. It's often extremely remote and must be equipped to handle any contingency. Regardless of locale, however, to drill or make hole, all rigs require the same basic systems. One is the rotating system that turns the drill stem and bit to literally make the hole. The second is the hoisting system that raises and lowers the drill stem and bit in and out of the hole. The third is the circulating system that pumps drilling fluid down the drill stem and back to the surface. And the fourth is the power system that makes everything work.
We have a can rig top drive. It's equipped with a 1,000 horsepower DC electric motor. It's run off our electric SCR house, and it turns the drill string, which in turn turns collars and bits on the bottom. We're turning about 100 RPMs right now. Penetration rate is probably 20 foot an hour. The type of bit we're using is a PDC bit, and we're turning it, which it in turn is cutting the rock.
The rotating system is ingenious technology and is at the heart of the drilling process. The bit is the primary tool in this system. As the bit rotates, it cuts the rock to make hole. Drilling fluid, a carefully engineered liquid, passes down the drill stem and out special openings or jet nozzles in the bit. The jets of fluid clean the bottom of the hole by moving cuttings away from the bit. Drilling fluid then carries the cuttings to the surface. The drill stem rotates the bit, which in turn is rotated by one of 2 types of machines on the surface. Here's a rotary table and Kelly. The Kelly is a square or hexagonal 40-foot length of pipe that threads into the top of the drill stem. The flat sides of the Kelly split into a corresponding square or hexagonal opening in a drive bushing, which fits into the rotary table. As the rotary table turns, the drive bushing and Kelly turns, and thus the drill stem and bit. Above the Kelly is a device called the swivel. The swivel allows the Kelly to rotate and provides a passageway for the drilling fluid to flow from the surface to the bit below. A second kind of rotating system is the top drive. The top drive has a powerful built-in motor. The motor's drive shaft screws directly into the drill stem. A top drive replaces the Kelly, rotary, and swivel. It suspends the weight of the drill stem and rotates it too. At the same time, drilling fluid flows through the top drive and into the drill stem and bit below. A top drive allows the crew to drill ahead with a 90-foot stand of pipe instead of the 30 feet typical with most Kellys. With a conventional Kelly and rotary, crew members have to make 3 connections to drill 90 feet. With a top drive, they have to make only 1 connection to drill the same distance. Using a top drive reduces the number of times the crew has to stop drilling to add pipe, and typically reduces drilling time by 25%. Above either a top drive or a Kelly is a large hook and the rest of the hoisting system. The hoisting system suspends the heavy weight of the entire drill stem in the hole, a hole that can be 10, 15, or 20,000 feet deep or more, and requires tons of pipe before the well is complete.
The drawworks is what, picks everything up, slacks it off, whatever. We got an 1 3/8 drill line. Our mast is rated at 1 million pounds, and our substructure is rated at 1 million pounds.
On most wells, the hoisting system raises and lowers the drill stem hundreds of times before the well is complete. The hoisting system includes the mast, or derrick as it's usually called, the blocks, the wire rope, and the drawworks that reel the wire rope in and out. A mast or derrick is one of the most distinctive things about a drilling rig. It's a structural tower that suspends and supports the hoisting system and pipe. At the top of the derrick is the crown block, one of 2 blocks in the system. The other block is the traveling block. The wire rope drilling line goes between the traveling block and crown block and carries the weight of the drill stem. The wire rope is also spooled around a rotating drum inside a large hoisting machine called the drawworks. Like a giant winch, the drum turns to release the wire rope and reverses direction to spool it in. Together, the derrick, blocks, wire rope, and drawworks suspend and move tons of drill stem in and out of the hole.
The mud, it brings the cuttings up to keep it clean around a bit. And the mud, like I say, it keeps it cool, keeps your bit cool. And with a PDC bit like we're drilling with now, you have to have a certain amount of gallons per minute for it to actually do what it's supposed to do.
Drilling fluid, or mud as it's called, is mixed in steel tanks. The mud tanks can hold a lot of mud, up to 25,000 gallons, or 600 barrels on big rigs, and some hold even more. Once the mud is ready, it goes downhole. A heavy-duty mud pump moves the mud from the tanks to the swivel or top drive, down the drill stem and to the bit. When the mud exits the bit, it goes back to the surface, carrying the cuttings made by the bit. Once back to the surface, it flows over a shale shaker and through other pieces of equipment. The shaker and other equipment remove rock cuttings and sand from the mud. Then the clean mud goes back down the hole again to be used over and over. All in all, it's a very efficient system and is absolutely essential to rotary drilling because the mud brings the bit cuttings to the surface. What does it take to run all the equipment on a rig? What power drives the rotating, hoisting, and circulating systems? Rig power comes from internal combustion engines.
I'm the rig supervisor. I'm over 4 crews. I have 2 crews a day, each work 12 hours. And they work 7 days on, 7 days off. I work 7 days on, 7 days off. We're out here 24 hours a day. Anything that breaks or tears up, whatever, we make sure it's fixed. Make sure we have rig supplies to fix it. I work with Marathon, company man. It's his well. He tells me what he wants done, what he wants, weight on the bit, pump pressure, gallons per minute, how many hours he wants to run the bit. And he tells me, and I, in turn, tell my crew. I'm out here to make sure everything's done in a safe manner. If there's any questions, you know, they come to me and ask, and I try to work with them on it.
The operating company, usually an oil company, retains the legal right to drill in a particular location. Usually they hire a drilling contractor, a company of drilling specialists. The tool pusher, or rig supervisor, is the contractor's top hand on the rig. He oversees 2 or 3 crews per day to maintain drilling 24 hours a day, 7 days a week. He lives and works on the site and is responsible for the success of the operation. As such, he's available to the crew at any time, as well as to any of the subcontractors that may be hired for specific jobs. Each drilling crew on a land rig includes a driller, a derrickman, and 2 or 3 rotary helpers. Offshore is the same, except they also hire additional workers called roustabouts. The driller works from a control console on the rig floor and directs the rest of the crew. He is directly responsible for the drilling of the hole during his shift, or tower, as it's called in the oil industry. Another member of the crew, the derrickman, handles the upper end of the drill stem from the monkey board when the crew is running pipe into or out of the hole. When the bit is on bottom drilling, the derrickman works at ground level on the drilling mud, making sure it meets the specifications for drilling a particular part of the hole. Depending on the size of the rig, its equipment, and other factors, a drilling contractor usually hires 2 or 3 other crew members called rotary helpers or roughnecks for each tower. The rotary helpers handle the lower part of the pipe when they're tripping in and out of the hole. When the bit's on bottom and drilling, the roughnecks help maintain the rig, repair it, and keep it clean and painted. And offshore, 5 or 6 roustabouts load and unload equipment and maintain the rig. Drilling a well can bring surprises. To keep people safe, emergency procedure drills are a part of every crew member's life. High-pressure fluids can enter the hole while drilling. The drilling fluid in the hole is the first line of defense against blowouts. It maintains pressure in the hole to keep formation fluids from escaping. If the formation fluids exert more pressure than the drilling fluid, however, they can enter the well bore and travel to the surface. If not handled properly, here's the result: a blowout. Avoid this, high-tech equipment and personnel constantly monitor what's happening downhole. They work together to make sure the crew handles the situation in a safe and effective manner. Offshore, where the rigs are on the water, emergency procedures also include drills for abandoning the rig if necessary. But because crews are so well trained, their safety record is outstanding.
One of the amazing things is people take for granted, and they pull up to a gas pump and get gas, that right here where we're at right now, this is the first journey that we go on. This is where we do the exploratory work. We drill wells, we're hunting oil, we're hunting gas. It's real interesting work to drill down and see the cuttings coming back. Most people, when they pull up to a gas pump, you know, they take it for granted or they don't have any idea of where this came from.